So today we will introduce our capstone project, the SQL engine for the Excel files. My team includes the Chasula and Quay. So first I will introduce the problem statement. Um, when we use the Excel file, Excel table, usually we need to merge two Excel tables on the same column. Yes, for example, in this we have the race table and the house table, and we want to join merge the two tables by the house name. So usually in the Excel we also use the VLOOKUP functions. However, if there are more than two files and the operation will become so complicated, and because our team is very familiar with the SQL engine, and also we propose the problem whether we can use standard SQL query like this one from the writer CSV join the house CSV on the house name, and then we can get the merged tables. So this is the problem we want to solve. And based on this statement, the left part is the natural SQL engine, and we can input some SQL queries, and it will be processed by the query language process. Usually it includes the parser and the optimizer, and then it will be processed by the database management system engine, and then it will to find some content from the physical database. So this is the natural SQL engine for database, and then our team proposed whether we can implement a SQL engine for the Excel files, and then we can using the SQL language just on the Excel files. So we propose this architecture for the SQL engine. So we can input some SQL queries, and it also we will implement the new Excel files query language processor. We can using the parser to parse the SQL queries, and then we can implement some executor for the Excel files, and then we can using the SQL query to get some content from the Excel. Yeah, and then the Chasula will introduce the basic SQL language. Yes.
I guess we all know the basic SQL structure. So the SQL statement is a valid combination of tokens introduced by a keyword. So in this case, here's some examples. So what is the keyword over here? The keywords are, for example, the select, the from and where, and the order by. And then following that, we could see the country ID and countries and region ID, all of that. And those we call identifiers. And those are the names given by the data designer or system users. Here we can see one example over here. So it's saying that from this file, we want to select student ID, first name, last name, and then we combine the first name and last name. So here's just some basic structure of SQL language. And then next, I want to introduce, I want to introduce some of the commands that we want to implement. So first of all, it's from command. So this loads a exact file and then print its contents to the standard output. And then preserving the same column. And then the second one is a select comment. It lets you pick particular columns from the loaded database and display only those. For example, here we have from and select. So we want to say from this country.csv, we want to select the country code, continent, and also country pub. And then next, here's a SQL commands take. So it lets you limit the amount of output to display. For example, here we want to say we just want to take 10 columns from this file. So say that the city ID we only have 10. And then the next one, we also have this order by command. This command lets you sort the database by a single numeric column in descending order. So in this case, in this example, we are saying that, okay, from this city.csv file, we want to take 10 column and then order by city.pop, city population. So we could see that the city pop population is the last column, and we could see that it's decreasing. It's in descending order. And then the next one, we have a join. So this is a little bit complicated comment. So it allows the user to combine multiple Excel files based on a common column. So the example over here is, so we want to say that we join this country.csv and then the language.csv. So we want to join this the country code of them with the city.csv. Then the next. We also have this count by. So what does it mean? It takes a single column name and reduces the data set to only 2 columns. A specified column after count by, and a count column with the number of times that the value of the specified column appears in the data set. So what does it mean? We can see that here we have an example. We're saying that from this language.csv, we want to count by what? Count by the language and then order by the count. So here, what do we mean is here we could see that the language English is counted like 60 times. It means that the language English appears 60 times, and then the Arabic, this language appears 33 times, and then the Spanish, it appears 28 times, and etc. Then the next one, and the distinct command, it's pretty simple. It's just saying, well, inside the table, a column often contains many duplicate values, and sometimes you just only want to list the different values. So the distinct command like allow you to list all of those distinct values. And then the next one, and this will introduced by Kui.
Oh yeah. I will introduce the project architecture for this Capstone project. The user in this architecture, the user will using the client, and it will include some SQL query statement, and then this statement will be processed by the parser and optimizer's model, and this query will be translated into some SQL comments as Katsura's introductions, and then the query language processor will get these SQL comments, and it will process according to the comments, such as the from executor will process the from comment. The selector executor will process the select comment, and the join executor do the same thing. Yes, and then after this pipeline processing, it will get the responsive result, and it will send back to the client. So this is the project architecture, and the Katsura will introduce the SQL language parser model.
So in this in our SQL engine, obviously we need a parser. So what is a parser? It means like once a user command is received, so it first needs to be parsed, and which involves translating from what is essentially a textual format into a list of parameters. In our case, we will translate it into a list of parameters, and then it can be easily manipulated by the next step, which is this SQL engine, the process which will do the actual work. And then I also have an example of a parser. Next slide, please. This is the parser example. So for example, we have a command. The user input this kind of command from city and order by and all of those, and then the parser will parse it into this kind of a list of parameters. So we can see that we have all of the keywords at the index 0, right? We have from, order by, take, they all at the index 0, and then the index 1, or we could see that it's the file, or it's all of the things that we want to select from the file, and then the all of the keyword here, like from, the order by, the take, it will act like a function, and then it will take the second index as a parameters, and then parse it into the SQL engine. And then next is.
Yeah, so I will introduce the executor example. So as we proposed in the start of the slides, we will have two tables. The first is for the race and the second is the house. We need to merge these two tables by the same column, the house name, yes. So as the project architecture shows, first we will to read the read CSV file is also Excel file, and using the from executor to get the right data. And for the house CSV file, we also using the from executor to get the house data. And then these two data will send to the jointer executor. It will do the join comments process, and then the result will send back to the client. So for this example, with this so-called query statement, it will be translated by the parser and then sent to the executor model, and it will send back to the response result to the client. So this is the executor for the join. And I also will introduce how our team to implement this SQL engine. We have two solutions to implement this SQL engine. The first is using the pandas. For example, the pandas support the join, and all the data for the pandas is a data frame. And for example, the data frame will load the def and the other, and then the def can join on the other, and it can get the results. So this picture shows the example for the pandas to implement the join. It's very easy because the pandas have implemented the join. And the second implementation solution is using the NumPy based on the Python. Yeah. So the NumPy will support some basic functions such as the sort. So we can implement the order by comment based on the sort. Yeah, we can load the Excel files into the NumPy and using some built-in function to implement the order by comment. So eventually we using the NumPy because we think it's more challenge for us to implement based on the NumPy. And also we implemented this SQL engine based on NumPy. We also want to extend this SQL engine into the pandas because pandas we can to register the custom access, and then we can using this SQL engine in the pandas. So this is the extension for the pandas to using the SQL engine. Then we will introduce some test case, yeah, for the project.
Yeah, so this is a parser test case. So in this case, we just basically we use the unit test, and in this case, we just want to know that if we really can translate this kind of user command, for example, the first one, the from city.csv and order by city_pop, if we actually can translate it into a list of command with parameters. So, and then the test case shows it's okay, it's succeeded.
And then I will introduce the basic executor model test case. So I have shown the from. Yeah, so from the Excel files data, the first 10 record is shown as here, and then we can using the from command processor to load the data, and then to list the column names, and we will implement a test case for this from executor. Because the from executor is really easy, so we just using this test case to demo the total process for the executor. And we have also to implement the join executor, the out by executor, and the count by executor. And we have introduced the two separator model, and we will compile the two separated model into one SQL engine. And as this architecture shows, Casula has introduced the parser models implementation, and I have introduced the executor models implementation. So this is a SQL engine to compile to merge two parts. So we can show the test join function. The first is to input some SQL query, and then the parser model will pass this SQL query, and we can using the executor. It means query. Its query model will get the parser's comments, and then we can using the query to do the processing, pipeline processing, and then we can check the results. And we can check the column's name and the desk ID. Yeah, and this is for the join test case, and we can show we have passed all the test case for the test join and tester out by and test from. Yeah. So this is the total capstone project for us, including the introduction, the SQL engine's introduction, and also the implementation solutions and the implementation and the test case. Thank you.